In lecture 22, we will be looking at the review questions related to the selection topic, which we did in the previous 3 lectures. We'll be looking at the if-else statement, and we'll be looking at the questions related to the switch statement as well as the conditional operator. So let's go to question number 1. Write a single C++ statement that prints too many if the variable count exceeds 100. So we just write a simple if statement saying that if count is greater than 100, then cout too many. So if this condition is true, then this cout will run. If this condition is false, then this cout will not run. What is wrong with the following code? Cn and this operator count, and in part A what we are doing is that either we should be using cout in place of cn, because or the extraction operator should have been used in place of the insertion operator, which we are using here, so that is wrong. In part B, if x is less than y, minimum equals to x, or else minimum equals to y. So here the parentheses are actually required over here, and so that and here minimum equals to x, we should also put a semicolon over here at the right at the end of the if clause before the else. What is wrong with the following code? Enter n, cn, we take the input from the user. If n is less than 0, cout is this is negative, try again, and then we say cn, and we again take the input cn. So the first thing is here we want to do these two statements. I mean, these two statements have to be run if this condition is true. So obviously we need some curly brackets over here just to make it a compound statement. Otherwise, if you don't put the curly brackets over here, then if this condition is true, this thing will run, and this thing will run regardless of whether this condition is true or false, because in the original scenario there were no curly brackets. So if there is no curly bracket, then the if statement ends at the very first semicolon. So if this condition is true or false, this cn would have run. But as far as the logic goes, I mean, we should put the curly brackets after the if statement. So there is more than one statement between the if clause and the else clause. They need to be made into a compound statement by enclosing them in braces. What is the difference between reserved word and the standard identifier? Reserved word is a keyword in a programming language that serves to mark the structure of a statement. For example, the keywords if and else are reserved words. Standard identifier is a keyword, it defines a type. Among the 63 keywords in C++, that relates to, I think, 1998 version of C++. If, else, and while are some of the reserved words, and character, int, float are some of the standard identifiers. Okay, so going to the logical operations which are required to make up the compound conditions and if statement, or maybe an else statement that state whether this is true or false. We usually write these conditions in the parentheses of the if statement. So state whether this is true or false. If false, tell why, that if this thing is same as this thing. So the best way to figure that out is always make a truth table. By truth table we mean that here I've written the standard explanation over here, that this is not the same as this thing. For example, if p is true and q is false, the first expression will be false, but the second expression will be true. The correct equivalent to the expression this thing is not p and not q. But the best thing is to do is you have to make something known as, if you are not so sure about it, you make a truth table. So let's say p we mean true, and this thing is true, and this thing is true, this thing is false, and this thing is false, and this thing is true, and this thing is false, and this thing is false. So if we take this expression over here, so first we need to do is, since parentheses are used, so obviously the first thing is going to be evaluated p or q. So p or q both are true over here, so p or q would be true, and since we have put a not over here, so we have a false over here. And if p or q, so that means that if the p is true and q or q is false, true or false would be true, but if you put a not operator, we have a false over here. And if we have this false and true, false or true, we have a true over here, but since due to this not operator, we would have a false over here. And false or false is false, but we have a not operator, so we have a true over here. So this is a truth table for this expression. Now let's make a truth table for this expression. So we have p or not q. So first we need to take it like if p and q both are true, so false or false would be false. So I mean, p is true, but you have put a not operator over here, so that would become false. And this q is true, I'm talking about this combination over here, so q is true, so not true is false. False or false is false or false is false. So this thing matches. So true and false, let's check this one out. So not P would be not true, would be false. I'm going to write it down, and this thing not and false would be false here, and not false would be true. So false or true would be true. So here we have true and here we have false. So that means that these two expressions are not same, because had these expressions been same, we would have the same output for the same order of combinations we have over here. So these expressions are not same, so best way to find out is using a truth table. We have another thing, if you want to remember, is that if we did not have the brackets, this is the logical operator precedence, that this not operator is always assigned first, then the and operator, and then the or operator. And you can see that the not operator is actually actually the minus sign over here, and the and operator is equivalent to the multiplication, and the or operator is equivalent to the addition, which we do with normal numbers. State whether this is true or false. If false, specify that not P is the same as not P. I think this is true. Reason is that let's take P, and we have only two combinations, true or false. So not P would be false and true. So let's take another example or another thing, not P. So P is true, not P would be false, then not false would be true, and not true would be false. So this is okay. So if we put P as false, so not false would be true, and then not true would be false, and not false would be true. So these expressions are same. Actually, if you multiply a number by a minus, or you multiply a number by minus 3 times, you will still get a minus sign. So behind the scene, the logic is that not operator is actually similar to the negation sign. State whether this is true or false. Specify P and Q or R the same as P and Q or R. So this is important, that if you make a truth table, that would be self-explanatory, that P and Q or R is not the same. The reason is that here the logical precedence is this thing is going to be evaluated first, because we haven't put any brackets over here, and this thing would be and the result of this expression would be ORed or the evaluated with R by logical OR operation. So this thing, I mean, if you have multiplication first and then addition, and then if you have addition first and then multiplication, obviously you don't have the same result. So if you take one example, for P, Q and R, if you are going to make truth tables, the examples are coming up in here. So if you're going to make truth tables, you have to go for about 8 combinations. So let's try making those. If I just do P, Q, R, you have to go from 000 to all the way to 111. I mean, like 001, 010, 011, 100, and I mean like 101, 110, 111. So all triple zeros to all ones, then you have to evaluate this expression, and then you have to evaluate this expression, keeping in mind that this thing is evaluated first, and the result of this expression, either true or false, is going to be ANDed with this variable. So I'm just going to do just one of these exercises. The rest of the exercises are for your assignment. I will be uploading this whole PPT file to the class stream folder. So state whether construct a truth table for each of the following Boolean expressions. I mean, these are all Boolean expressions here. So Boolean expression showing its truth value 0 or 1 for all 4 combination of truth values of its operands P and Q. Not P or Q. So I've tried developing that P and Q. So not P would be false here, and Q is true. So false or true is true, and true and false. Not P would be false. False or false is false, and the third combination is false and true. So not false is true, true or true is true, and the last combination is false. That would be not false actually, so that would be true or false is true. So this is the first thing, and the B part is P and Q or once again, I mean, we haven't put any parentheses over here, so this thing has to be kept in mind that the logical operator precedence is that the minus sign of the not is always applied first, and the AND operator, the multiplication, the logical multiplication applies second, and the OR operand is applied third, or the I mean after that. So if there are no parentheses, in this case there are parentheses, so whatever is in the parentheses is going to be evaluated first, and then the results of these two things with the not operation applied are going to be ended over here. So if we do this, so this thing is obviously going to be evaluated first, and this not P and not Q is going to be evaluated. Not is going to be applied to this Q, and not is going to be applied to P. So let's try doing it first. So P and Q, so P and Q both are true, so this thing is true, okay, and not P and not Q would be false, and false is going to be false. True or false is going to be true. Let's take this example over here. So this thing P and Q would be false, because P is false and Q is true. So I mean, if you multiply 0 with 1, you get 0. So or false with AND operation, and not false, sorry, yeah, not false is true. True and not true is false. True and false, this thing is also going to be false. So false or false is going to be false. Same is with these I mean, all these things. I would suggest you check it yourself. So if there is any error, because I've done it in Excel, so if there is any error, do let me know about it. Okay, use the truth table. Same question with the different set of exercise, whether the two boolean expressions in each of the following are equivalent or not. So I mean, this thing, is this equivalent to this thing? Not so sure about it. Let's try that. But whenever you have three operands, or whenever you have two operands, for two operands, the best thing is if you go from 0 0 0 1 1 0 1 1, or you can just say false false, false true, true false, and true true. So if you look over here, I have made the tables in reverse order, but it doesn't really matter. There is another way to make these tables. I'm going to explain that in a moment. And if you are going from three operands, let's say if you have P, Q, R, so you have to go from 000 to all the way to 111. So you have like 8 combinations over here. There is a very simple way to develop these truth tables. One is, if you have like two operands over here, this thing is going to be alternating between true false true false, and the next one would be alternating between true true false false. So I think you can figure that out, that if you have like 3 operands over here, so here we have just like 1 operand over here, so these are actually exactly the same. So here if you have 3 operands over here, so P, Q, and R, so this thing would be alternating between true false true false true false and true false. That's a way to make a table. If you just look closely, it's like 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. And the way to do that, if you just write it in alternative forms, true false true false true false true false, this thing would be true true false false true true and false false, and this thing would be 4 trues and 4 false. I mean, that's one way to write these tables. So if you're not happy with true and false terminology, you can use 1 and 0, which I find much more simple. So instead of writing like true to true, I would have written 1 1 1 and 1 1 0 in reverse order. It doesn't matter in which order you take. You take in the ascending order or descending order. Here the descending order is being taken. It's up to you, whatever your preference is. So P and Q and R, so obviously P, Q, and R is going to be evaluated first. So Q and R both are true, so 1 and 1, I mean the result of this expression would be, in the first scenario, would be 1, and 1 and 1 would be 1 or true over here. And same thing here, if you have P and Q and then you multiply, or then you have the AND operation with R, since all of them are with of equal precedence, obviously these two expressions are same. I mean, you have similar 3 logical multiplications. Here if you look, if I go back a little bit, here we have a logical multiplication and a logical addition. So I mean, these two are they are not the same, because if you multiply first and then add numbers, and then if you add numbers first and then multiply, obviously results are not same for all the possible combinations. So I mean, these are self-explanatory exercises, sorry about it, and these are self-explanatory exercises in which you have to make the truth tables and figure out the output. yeah, same example, P or this thing, and or P or Q and R. So obviously you have to make like 8 combinations from all ones to all zeros, or all zeros to all ones. And P or Q, let's take the any one of the example. So let's take this example over here, true, false, false. So let's take this thing, that here the parenthesis operation is going to be happening first. So we have false and false, Q and R are false, so obviously result of this thing is false, sorry. And P is true, so P true or false is going to be true, so we have true over here. So now if we take P or Q, so true or false is going to be true, and R is false, so this thing would be false over here. So obviously whenever you have just like um, one discrepancy or one difference, you can just say, I mean, without even evaluating any further, you can say that these two expressions are not equivalent. In exam, if you are asked to make a truth table in full, then you have to make the whole truth table. If you are just asked to prove that these two expressions are not equivalent, you just make a truth table, and whenever you see the very first difference, you can just stop right over there and say, since these outputs are not same for the same order of inputs, so therefore these two expressions are not equivalent. There are other ways to prove this. There are some boolean algebra which you will learn in the course of logic design and switching theory, but here we are just dealing with the conditional statements for the if statement. So conditional expressions, or the boolean expression for the if statement, this is just an exercise to figure out the output of these conditional or boolean expressions. What is short circuiting and how is it helpful? Short circuiting is used to describe the way C++ compiler evaluates the compound logical expressions. Obviously, if this thing is true, if this expression is true, then it doesn't need to evaluate this expression, because it knows already this thing is true, and if we have an OR operation, so it doesn't need to evaluate this thing. Similarly, if this thing condition is false, then it doesn't need to evaluate this expression, because any logical operation, any AND operation with a operand as false is going to be evaluated as false. And similarly here, if this condition has been true, if this condition is true, then we do not need to evaluate this expression. Reason is because we are performing the logical OR operation over here. So or, I mean, true or anything, either it's false or true, doesn't really matter, the whole answer would be true. So that's the if x is greater than 2, then the first expression, then y will not be evaluated. If x is less than or equal to 2 in the second expression, then y will not be evaluated. In these cases, only the first part of the compound expression is evaluated, because that value alone determines the truth value of the compound expression. What is wrong with this code? If x equals to 0, C out x equals to 0, else C out x equals to, I mean, it's just a statement not equals to 0, just a string over here. So this is the most common error. Here we are using the assignment operator, we are not using the equality operator. So that's a big problem here. For example, if the x programmer probably intended to test the condition x, whether x is equal to 0 or not, by using the assignment operator instead of the equality operator, this thing double equals to sign, the result will be radically different from what was intended. For example, if x has the value of 22 prior to the if statement, then the if statement will change the value of x to 0. So that means, and this will return, I've explained that in the previous lecture, and this x equals to 0, since we have assigned the value of 0 to x, the x will now have the value of 0, and this whole expression is going to return 0, false. So this thing is not going to run, this thing is not going to run, and this is going to say else is not equal to 0. And had this been like if x equals to 2, this would have returned true. Even though this is just wrong way to write a check, or conditional check, whether some value is equal to something. If you want to check whether some value, if you want to check x is equal to 2, you need to write the equality operator over here, not the assignment operator. What is wrong with this code? If x is less than y less than z, C out x less than y less than z. Actually, the programmer probably intended to check that x is less than y and y is less than z. This code was written, this code will compile and run. This is not a compile time error, this is not a runtime error, this is actually a logical error. For example, if the values of x, y and z were 44, 66 and 22, then the algebraic condition is false, because 44 is less than 66 is less than 22. but the code will be, since we have here we have the same precedence here, because we have the same operator. So this condition, this code will be evaluated from left to right, because we have the same precedence in this. We have checking whether x is less than y and less is less than z. So this thing will be evaluated from left to right. So first, the condition x is less than y will be evaluated as true, because 44 is less than 66. So the answer for this condition would be 1 or true. 1 less than, and the value of z is 66. So 1 less than 66 is also true. So the output statement will execute saying that, which is an error, that 44 is less than 66, then less than 22. So remember, whenever we have the multiple operands and multiple operators and all have the same precedence, which we have explained that in the previous lectures, the expression is always evaluated from left to right. So this thing, x is less than y, is going to be evaluated first, and the result of that expression is going to be compared with z. So x less than y, the result is either 0 or 1. Either x is less than y, which is true, or x is not less than y, which is false. So if in this scenario we are not so sure what the values of x, y and z were, but if, let's say, if the values of x and y and z in 44, 66 and 22, 44 is less than 66 is going to be evaluated as true, because 44 is less than 66. Therefore the answer for this expression, x less than y, is going to be 1, and 1 less than 66 is actually true. So this statement will run. So this is a common error. Keep in mind whenever you are not so sure about it, whether some expression is going to be evaluated first and then next, either use the AND operator if you want to check that, or use parentheses if you want to be even if you are using parentheses, it would have still have the same result. So make sure you convert the problem statement into the correct logical expression. Construct the logic expression to represent each of the following conditions. The score is greater than or equal to 80 but less than 90. Answer is either n or n. N is even but not 8. CH is a capital letter. So score is greater than or equal to 80 and score is less than 90. Okay, but less than 90. So yeah, this translates to and. Answer is either n or n. So answer equals to, or the equality, capital N, or answer equal. Answer is basically, I think, a character variable, right? N is even, obviously n percentage 2 or n remainder 2 should be 0, should equal to 0. N is not 8, and n is not 8. So but translates to and here. CH is a capital letter. So I think if you want to do it, I think it's either you can take the ASCII value of A of 65 and Z is, I think, 97. I don't remember correctly, you have to take a look, or you can compare this CH variable is greater than or equal to A and less than or equal to Z. So obviously behind the scene it will be comparing the integer values of these characters. So yeah, A 65 and Z, I think, is 97 if I'm not wrong. So we can compare that CH is greater than or equal to A, I mean A is included, and less than or equal to Z at the same time. Construct a logical expression to represent each of the following conditions. N is between 0 and 7, same thing. N is between, so you have to put in the range but not equal to 3. So this but is going to be translated to n over here. So n is greater than 0 and n is less than 7, and n is not equal to 3. N is between 0 and 7 but not even. So n percentage 2 or n remainder 2 not equal to 0. Okay. N is divisible by 3, so n is divisible by 3 but not by 30. I think I forgot to write that. N is divisible by 3 but not by 30. So if we try to write that, so n should be divisible by 3. So if I write n percentage 3 should equal to 0, so that means n is successfully divisible by 3 but not. So but and that means n operator, and should not be divisible by 30. So obviously if we put n percentage 30, I mean if it's equals to 0, that means it's successfully divisible by 30. So we should put not equal to 0, so that means it's not successfully divisible by 30 over here. CH is a lowercase or uppercase letter, so ch is greater than a, or and ch is less than c, or ch is greater than a, or ch is less than z. So this is small letters. I think they start I think this is 65 and this is I don't know, 92 or some number, ASCII code. You have to check the ASCII table over here. So what is wrong with this code? If x equals 0, if y equals to 0, see out x and y are both 0. This thing in here, the programmer clearly intended for the second output x is not 0 to be printed if the first condition is false. So here it says that if x equals to 0, and then it says if y equals to 0, x and y are both 0, else see out x is not 0. So if this condition is false, it should be printing this thing, but here this else is actually coupled with the last if, so we have to keep that in mind. So let's read the explanation over here. The programmer clearly intended for the second output x is not 0 to be printed if the first condition is false, regardless of the second condition y equals to 0. So I mean which we are checking for the equality. That is, the else was intended to be matched with the first if, but the else matching rule causes it to be matched with the second condition, which means that the output x is not 0 will be printed only when x is 0 and y is not 0. The else matching rule can be overridden with braces if x equals 0, and then we put the braces over here. If y equals to 0, see out are both 0, and that's it. Else see out x is not 0. So in this case, this else is going to be matched with this thing, because this code block ends with this curly bracket over here. So this code block is here, and this code block belongs to this if, and this else is now matched to this if. So if this condition is false, then we are just going to print x is not going to be 0. If this condition is true and we enter this block and y is also 0, then we are going to print x and y are both 0. So because this if condition was true and it actually ran, and this ran, so this else statement is not going to run. What is the difference between the following two statements? If n is greater than 2, and then we put the curly bracket. If n is less than 6, see out okay, else see out not good. If n is greater than 2, if n is less than 6, see out okay, else see out not good. So watch out, where are the curly brackets? Here the curly brackets start from here and here. So let me write this code again. Actually, first make this thing. This code is actually difficult to read because it does not follow standard indentation convention. The first statement should be written if n is greater than 2, and then in the if n is less than 6, see out okay, else see out not good. The braces are needed to override the else matching rule. This else is intended to be matched with first if, so this else is going to be matched with this if over here. And the second statement should be written if n is greater than 2, and if n is less than 6, see out okay, else see out NT, and then this else is going to be matched with this thing. Here the braces are not needed because the else is intended to be matched with the second if. Now coming back to the original thing, the first statement, the else is matched with the first if. In the second statement, the else is matched with the second if. If n is less than equal to 2, the first statement will print not good, while the second statement will do nothing. If n lies in this range, both statements will print okay. If n is greater than equal to 6, the first statement will do nothing, while the second statement will print not good. What is fall through? A fall through in a switch statement is the case in which does not include a break statement, thereby causing control to continue right on the next case statement. How is the following expression evaluated? This is a conditional operator. So if this condition is true, this thing is going to be returned, otherwise this expression is going to be returned, and this expression is going to be evaluated. If this thing is true, then this thing is going to be returned, otherwise this thing is going to be returned. So first, if x is less than y, the expression evaluates to -1. However, if it evaluates to 0, if x is equal to y, and it evaluates to 1 if if x is greater than y. So if x is less than y, this thing is true, so this thing is going to be return going to be -1. If this condition is false, so this expression is going to be returned, and this expression is going to be evaluated. So we're going to check if x equals to y, then 0 is going to be returned. If x is not equal to y, that means x is probably greater than y, because we would have arrived here because x was less than y. So if x is greater than y, then 1 is going to be returned over here. Write a single statement that uses the conditional expression operator to assign the absolute value x to a, b as x, and it says x is greater than 0, and if x is greater than 0, then x is going to be returned, otherwise minus x is going to be returned. Write a single C++ statement that prints too many if the value count exceeds 100 using an if statement using the conditional operator. It's pretty simple. If count is greater than 100, count too many. Count greater than count greater than 100, if condition is true, is going to print too many, otherwise going to print absolutely nothing. In the next lecture we are going to look at the practice problems related to the selection topic.